So hi and hello. Welcome to our channel named Algo Exploration. My name is Sabi and from today onwards we will going to learn about sorting. So actually there are plenty of sorting algorithms, but we will going to learn only 9 sorting algorithms. So starting with bubble sort, then we will go at merge sort, quick sort, selection sort, insertion sort, counting sort, radix sort, bucket sort, and in the heap section I'll explain heap sort. So every sorting technique has its own advantage and disadvantages. Just like linear search is better than binary search when the data is not sorted, here also every sorting technique has its advantages. So let's start by the first sorting technique, that is bubble sort. Okay, bubble sort is a simpler sorting algorithm that just compares the adjacent element repeatedly. Due to this, at the first pass, the largest element go at its correct place, that is the last place. So let's take an example and see. At first, we will compare these two elements. So since they are in the correct place, we will not do anything. We just simply write as it is. Now after that, 50 and 20 will be compared. So they are not at its correct position, so we will swap it. 20 will come first and then 50, then 40, 60, 70 and 50. After that, 50 and 40 will get compared, and here also they are not at its correct position, so we will swap it. 40, 50, 60, 70 and 50. Again the next two elements will be compared, that is 50 and 60, and they are at correct position, so we will not do anything. Now again the next two elements will be get compared, 60 and 70, and they are at correct position. So 10, 20, 40, 50, 60, 70 and 15, and at last these two will be get compared, and 70 is greater than 50, so we will swap it. Now you can see that in array A, 70 was the largest one, and at the end of the first pass 70 is at correct position, that is last position. So in this way the bubble sort works such that the largest bubble will be at its correct position. Let's see the pseudocode for this. Now this is the pseudocode, name as bubble sort, passing parameter as array A, and we will run two loops actually. I is running from 0 to n minus 1 and j is running from 0 to n minus 2. Now at first we will check whether a of j is greater than a of j plus 1. If it is, then we will swap. Simple. So this loop will run for n number of time, and this loop will run for n number of time. So it will be n square since it is nested. So time complexity will be order of n square, and space complexity will be order of 1. Due to this, we can say that this is a in-place sorting algorithm. What do you mean by in-place? It means while sorting we don't need extra space. At that time we say in-place sort. If we need extra space, then we say as outplace. Now let's dry run this code. This is our array. Now firstly we will compare the first two elements, that is 5 and 4. Since they are not at correct position, we will swap it. So 4 will come first, then 5, 3, 2 and then 1. After that we will compare the next two elements, that is 5 and 3. They are also not at correct position, so we will swap it. So 4, 3, 5, 2 and then 1. After that next two elements will be compared. They are also not at correct position, so 5, 3, 2, 5 and 1. After that 5 and 1 will be get compared, so this will be 4, 3, 2, 1 and 5. 5 is at correct position since it is the largest element in the array. Now our array will look like this: 4, 3, 2, 1 and then 5. Again the first two elements will be get compared. Since they are also not at its correct position, we will swap it. So 3, 4, 2, 1 and then 5. Again 4 and 2 will be get compared and they are not at its correct position, so we will swap it. 4 and 1. Now these two elements are at its correct position, so we will not swap it. We just simply write. Now this is our second pass which got completed. Now at the third pass the array will look like this: 3, 2, 1, 4 and 5. Again the comparison will happen between 3 and 2 and it will look like this: 2, 3, 1, 4 and 5. Now this is our third pass, and after that the array will look like this. So again the comparison will happen between 2 and 1. As we can see that at the first pass the largest element will be at correct position, and in the second pass the second largest and the largest element will be at correct position. So we don't need to go at that place. So here is the optimized pseudocode, that is I will be going from 0 to n, but j will be going from 0 to n minus 1 minus I. Due to this, the largest element that got its correct position before that pass, we will not go till that point. And again a of j, if it is greater than a of j plus 1, then we will simply swap it. So here let's analyze the time complexity here. At the first pass there was n minus 1 comparisons. Like you can see that if there are 5 elements, then there was total 1, 2, 3, 4 comparisons. So therefore when there are n elements, then n minus 1 comparison. At second pass there will be n minus 2 comparisons. At third pass it will be n minus 3 comparisons, and so on. When there is n minus 1 pass, then there will be n minus 1. This will be nothing but 1 comparison only. Now if you sum up all the comparison, this will be 1 plus 2 plus 3 and so on till n minus 1 comparisons. So this is nothing but a summation series that will be n minus 1, n minus 2 by 2. That is nothing but n square only. So time complexity will be order of n square, and space complexity is still order of 1. Now we just reduce some comparisons, but still the time complexity is order of n square only. Now how can we reduce? Now let's take this example. Now first these two elements will get compared. They are at its correct position. 2 and 3 will be get compared, and still they are at its correct position. So we will write as it is 1, 2, 3, 4 and 5. Now again 4 and 5 will be get compared, and they are at its correct position. So we will write as it is 2, 3, 1 2 3 4 5, and at last 4 and 5 will be get compared and they are at its correct position. So we will write as it is. So we can see that here, since the data is in sorted manner, we are still comparing each and every element. So why do we need this? Here is the solution. If there is no swap occurred in the inner loop, that is, we can say that the array is already in the sorted manner. So how we can we code this? That is, in the inner loop, we will actually put a flag that saying that if we do any swapping, then that flag will become true, and we will got to know that there is a swap between the elements and the data is in not sorted manner. And if there is no swap, then the flag will be false. So we will just break from the loop and we can return the array. So this is the pseudocode. Here also the I will be running from 0 to n minus 1, and we will initially, after the first loop, save flag as false. That means till now there is no swap. Now j will be running from 0 to n minus 1 minus I, and we will check whether a of j is greater than a of j plus 1. If it is, then we can say that there will be a swap. So we will set flag as true. Now after coming out from the inner loop, we will check whether flag is equals to false. If it is, then we will just break from the loop and we can see that the data is in sorted manner. So here there will be three cases: best case, average case, and worst case. Worst case, as we know that it will be order of n square. But when the data is in sorted manner, like 1 2 3 4 5, we can see that there is no swap. So since the flag will be false, it will come out from the loop, and there will be only n comparisons, not n square. So order of n. This will be our best case. So it will be order of n. Now what will be the average case? Now since we are dealing with sorting, there will be only minimum chances that the data will be in a sorted manner. So when we want to find the average case, what kind of data come as the input? Here in this case, most of the time the data will be not in a sorted manner. So we can say that will be our average case. So since the data is not in a sorted manner, we will say order of n square. Now what about the space complexity? It will be still order of 1. Now this is our simplest sorting algorithm, that is bubble sort, and in the next lecture we will see the merge sort. So thank you.